Hello friends and colleagues, it's MoNaCo here with our sixth homework note video, and this is where we're going to switch from going to be talking about matter, compounds, elements, mixtures, how to separate them, to measurement. This video is about scientific notation, which is a kind of a running theme through all of science and even some mathematics as well. By the end of this lesson, you should be able to write a very large number and very small numbers in scientific notation and be able to convert a number that's been written in scientific notation back into the standard notation. Okay, we as scientists use large and small numbers very often. So we had to create this scheme, an idea, a way to write very big and very small numbers on paper that didn't take up the entire piece of paper. Okay. For example, this number that you see here, 602 sextillion, 200 quintillion, would take up a lot of space if you had to write it out. Not only that, but all that space is zeros. This number is what we call Avogadro's number. Now, Avogadro's number is the number of particles in 1 mole of a substance. It's based upon carbon, the element C, having a mass of 12 grams. Okay. The focus today is we're going to learn to use scientific notation to express very large numbers like this and very small numbers like, oh, I don't know, 0.00000000015, which would be a very small number. A very large number like Avogadro's number is going to do some magic, and we're going to condense it. It's going to turn into something smaller, like 6.02 times 10 to the 23rd. That's much more compact, easier to use on paper, that is. It means the same thing as 602 sextillion, 200 quintillion, but it's much smaller to write. A number like this, on the other hand, is going to turn into something like 1.5 times 10 to the negative 9. Again, much more compact, means exactly the same thing, but it's easier to write on paper. So let's get to the meat and potatoes today. Scientific notation, method for expressing very large or very small numbers. For example, Avogadro's number, 6.02 times 10 to the 23rd. When we write numbers in scientific notation, we move the decimal place so that it is between the first and the second number, and that we call the mantissa. The number out in front has to be between 1 and 9. We arrange the exponent, the number to the top right of the 10, to represent how many places we moved the decimal. Okay, now we check our work. For example, this normal standard notation, 1.21230000000, I think it's 123 billion is how we'd say that one. It's normal standard notation. Expanded notation is another way to call it. This is the scientific notation for that. And essentially, we have decided to put the decimal place here so that the mantissa, the number to the left of the decimal place, is between 1 and 9. And then we multiply times 10, that's always the case. And we decided 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because that's where the decimal place started. And since we moved it up to be between the 1 and the 2, we moved it 11 places to the left. So the exponent is 11. And the number that comes in front is just the numbers that are not 0. That's how I learned this stuff. Scientific notation allows us to get rid of all the zeros that you'd have to write on paper. So let's try a little bit of practice. Oops, slightly out of calibration there. Okay. Try a little practice. Write the following numbers in scientific notation. So the first things first is you decide where the decimal place is now and where the decimal place needs to end up. Okay. So if we're going to move this decimal place from the end, 1, 2, 3, 4, 5, 6, 7 spots, that means our exponent is going to be times 10 to the 7th. And our mantissa is going to be 3.4 times 10 to the 7th. That's taking a large number and turning it into scientific notation. This is the equal sign arrow. That equals that. Now in this next case, we are going to take a very small number and write it in scientific notation. We started our decimal place right there, and we want to end it up right there so that the number that we're dealing with is between 1 and 9. So we start with 6.7 because that's where the decimal place is going to end up between the 6 and the 7. And we always have a times 10. That's just every piece is going to have that. And we decide we move the decimal place. 1, 2, 3, 4, 5, 6. Now, if you wrote times 10 to the 6, you would be wrong because that would make it a very large number. This is times 10 to the negative 6. So essentially, if you move the decimal place to the left, the exponent's going to be positive. If you move the decimal place to the right, the exponent's going to be negative. Okay? This next number doesn't have any zeros in it, but it can still be written in scientific notation. The decimal place is currently right there, and we want the decimal place to be between the first and the second number, right here. We need it to end up right there. So you can go ahead and write your decimal automatically. 2.5864 times 10, because every piece of scientific notation has times 10 in it. And we decide we moved our decimal place where? 1, 2, 3, 4 spaces to the left, so that's going to be positive. So that's times 10 to the 4th. Okay. So a little bit more practice. We're checking out. Write the following in standard form. Okay, this is when we take a number from scientific notation and turn it back into what it was. Okay, so 5.7 times 10 to the 8th. Well, times 10 to the 8th is a positive number, which means you move the decimal back to the left. So in this case, we are going to have to be moving the decimal place to the right 8 places. So we start with 5.7, and we got to move the decimal place to the right 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. Put it in. And then we fill everything else in between in with zeros. And so this is 570 million. 5.7 times 10 to the 8th is 570 million. So there's the expanded notation from the scientific notation for a very large number. Let's do a very small number. Now, here you can see the exponent was negative, which means that we are going to make a very small number, which means we're moving our decimal place to the left 11 spaces. Yikes. Okay, so I'm going to start by writing 6, 3, 4. And if I started with the decimal place there, I got to move it 11 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's where the decimal place is going to end up. So we fill in all these spaces with zeros. And I don't even know how to express this number verbally. It's way more than a millionth, way more than a billionth of 1. It's a very, very, very small number. This would be on the order of the size of atoms or quarks or super subatomic particles. So very, very small number if we're talking about meters and such. So in conclusion, at this point, well, there's a little tip how to put this into a calculator if you need to. All calculators nowadays are capable of doing scientific notation, especially if you have a smartphone. You just tilt it sideways usually and you get the expanded keyboard. That's how you put it into a calculator using the caret key or the EXP key. We won't be having to do that too often in chemistry class, though. So now you should be able to convert a large or small number into scientific notation and convert a number in scientific notation back into the standard notation. So thanks very much for listening. Hope you have a good night.